Hi, everyone. Welcome to this live stream with Peter and Banugo. Joining me today is Chris Vachel from Gitpod. Welcome to the show, Chris.
Great to be here.
Yeah, so Chris is a CTO at Gitpod, and he had an interesting blog post, I think last week, about moving away from Kubernetes, and I think it was a nice topic to get him on the podcast to share about their journey. So, would you mind some introduction about yourself, Chris, and also maybe about Gitpod?
Sure. So my name is Chris. I'm one of the co-founders and the CTO at Gitpod. Gitpod provides automated and standardized development environments. And so what that means is, we as engineers, we all know this. It takes a lot of time to set up our development environment, keep that thing up and running. Studies show that that's to the tune of half a day per engineer and week. So it's a lot of time that is essentially wasted, really. Like it's not very productive work on setting up your dev environment. We reduce that to seconds. We take all this configuration work out and we do that by automating the setup and then making it really, really easy to just create these development environments. So that's what we do. We've been at it for a long time, as the blog post also outlined, several years at this point,
Oh, that's
and
nice.
that's really where we're coming from.
Oh, cool. Just some information. If you see me looking on the side, I have the YouTube chat on the side, so sometimes I
All as
check,
well.
and you don't think I'm distracted. So that's nice. We have somebody on the stream. I don't know. The name says B, and it says, "Hey, Chris and Peter." But hello, B, and nice to have you on stream. Uh, so, from what you mentioned about the dev setup, is this for like new employees or like for running, like the way we have staging environment, but just running your own dev staging or
Hmm.
dev environment? Is this shared between colleagues or is just one developer per environment?
Yeah, it's one developer per environment. It's very much like a good mental model to have is imagine you had a magic tissue box, except that instead of tissues, you get ready set up laptops. You can get as many as you want without all the economic downsides something like that would have.
Okay.
Um, and ecological downsides. So you can get a fresh development environment, as many as you need for
Okay.
whatever work you're doing. And these development environments aren't necessarily shared. You can choose to share them with someone else if you so choose, but the intent is very much that, much like today, you get your own that only you work in. In fact, it's even more than that in the sense that these development environments, say you have three. I think at this point I have two running at this moment. They're isolated from each other, meaning that if I mess up in one, I'm not destroying the other. And say I make a mistake somewhere, I accidentally delete my Git folder, or worse yet, install the wrong version of Python or something like that. I can just get a new one, and
Okay.
everything's fine again.
So I guess it's more like having your own virtual machine in the cloud or like a ready-made virtual machine.
And in a way, like technically, that's also what it is. Actually, like there isn't any magic there. Um, it is now, hence the conversation. And it always like the intention was always that it feels like that. You want to have this machine that is yours, except that the usual cost that's associated with something like this, the setup cost, but also the cost you're paying to AWS is less.
Oh, yeah. I think I saw a tweet probably 2 weeks ago or three. I think the folks at SST.dev, they're trying to set up like a dev environment and they had to get like an on-premise machine. And I think he didn't blog about it, but he described a bit of how they split the machine into environments so that they can run each of their workload. And it would be nice to also see his um, setup. But I think that is the kind of problem Gitpod solves. And I also used it. I think when I was trying to go through the labs or examples course rather from tempora.io, if you know tempora. it's a durable execution platform, and if I'm not mistaken, I think they are the ones, or maybe it's a different product that had Gitpod as part of their um, lab. So they have like a ready-made, probably like a script that takes you to a Gitpod setup, and then you have this code already there, and then you follow through the instructions and run the script. So I think that is also where it could also help out.
Yeah, we see a lot of people who use Gitpod in workshop settings. And also for, you mentioned onboarding, that's another big one where
Okay.
folks who come into an organization, like so many, especially in larger organizations, it's very common that when someone joins, it'll take them days before they can actually be productive. They need to get their machine, they need to get access to all the different things, and then they need to set things up. And we do drastically reduce this time. And a good
Okay.
amount of, like, one of the terms that we use to describe what we do is we want to make people ready to code, be always ready to code. And today, without something like Gitpod, there are a lot of steps that are needed in order for you to be ready to code. You need to check out your repository. You need to make sure all repositories, if it's a multi-repo setup, you need to make sure they're all in the correct branch, in the correct state, in the correct location. You need to make sure you have the right tools. You need to make sure your editor is connected to and set up primed for the right directory. And then you need to typically, compile this stuff, make sure npm is downloaded the internet, and there's a lot of stuff that needs to happen just for you to be able to actually dive into it. And that's not just true this one time when you join somewhere, be that a workshop or an organization.
Yeah.
It's also true as you progress, right? Like, you want to review the PR of a colleague, you now have to go and go through a very similar setup. You have to make sure you're on the right branch. You have to make sure that the dependencies are correct. You have to make sure that the things are built and possibly run the tests. Like, there's just a lot of stuff that you need to do today manually. And that's where something like Gitpod comes in. The category of these systems is called cloud development environments. And the cloud may be a bit
Yeah.
misleading. Happy to talk about that in a moment.
Kind of like, I think, code spaces as well. GitHub
Correct.
code.
Code spaces is in the same space. Yeah.
Yeah. And for the pull request part you mentioned, can I share the same environment for the pull request, or do we have to spin up the same copy for the pull request?
So you can choose to share it. There are three levels of sharing, I want to say. One is sort of in the let's the simple one, let's call it that, where I give someone else access to an environment I created. Right? I create an
Okay.
environment, I give someone else access to it. That works really well, but there's a number of question marks with it. It's the equivalent of me handing you my unlocked laptop, literally, including all my credentials and all that, right? So there's a bunch of question marks associated with that. It can be like, especially if there's high trust between the people who are sharing, that can be okay. The second way of sharing is where I create an environment. I start whatever service is being reviewed. Very typically, as part of a PR review, you want to try the functionality that is being reviewed. And sometimes the person doing the review isn't an engineer. Imagine a designer or QA person. They're not necessarily engineers, and they still need to be able to run the software. So what you can then do is you can set up such an environment, kind of like a preview environment, bring
Okay.
up the software, try it out. That's the second way. And the third is the one that is really fundamental to the CDE space, where you have these sort of reproducible automated recipes, and then you share the configuration, not the concrete instance. There's a lot of benefits to that too, specifically the fact that they're isolated. So one person cannot affect the work of another unless they want to, right?
Oh, that's interesting. I see this kind of like, if I put it in another words, it's like um, Docker for like code review or dev environment or preview environment, and that makes me curious, like what's in the box, like what makes this all happen, and how this has to do with Kubernetes.
Yeah. So it's interesting into Docker. Like the cool thing is this idea of having automated, reproducible development environments in different shapes or forms isn't exactly new, right? Like we've been trying to, like we as an industry have been trying to make this happen for a long time. Remember back in the day, things like Vagrant. It's also what
Yeah.
Docker set out to do, Dockerized, containerized development environments. The thing that those systems fell short of is the degree of integration that's necessary to actually make this a convenient workflow. And I think this is where we've taken the step that's necessary to make this a reality. In terms of how this functions and how this interacts with Kubernetes, when we started out 6 years ago now, but more than that, a long time,
Yeah.
we we looked at the space at the and saw that VS Code had just was just around the corner, was just gaining popularity, built on web technology, and Kubernetes was gaining traction. And so we looked at those two technologies and we're like, all right, we're now at the precipice of those two crossing streams. And so it seemed obvious to us at the time that if only, this is the reason I have this sign here. I don't know if you can read this. It says, "We do
Not.
this not because it is easy, but because we think it is easy. It is easy." It's a warning sign because so many times as engineers we go, "Hey, I just do this and that. It's going to be easy. It's going to be fine." Right?
Mhm.
That's how we started too.
And then you realize it's not as easy as you thought.
It is not, and we have really tried a lot. Like that blog post represents 5 years of my life. Like we've really, really tried a lot. And fundamentally, there are, I want to say, three challenges that arise from building something like this on Kubernetes, like building development environments on Kubernetes. And just as a precursor, I'm very specifically talking about development environments, right? This is not a statement about, in all generality, about the suitability of Kubernetes for workloads. That's not what we're talking about. There are a lot of really good reasons where Kubernetes, or places where Kubernetes fits well.
Yeah. And you didn't start using Kubernetes because it was a popular and cool kid in the blog.
Oh, that's
Because
100% why we used it. Oh, totally. Like, absolutely. Like, we looked at Kubernetes and we're like, yep, this is cool. Look at all the things it can do. Of course, 100%.
yeah, because I've been worked with a few organizations, and I also used to be like a big proponent of Kubernetes and loved it, but having seen like a couple of organizations and they have so simple workload, and then it gets complicated because of their use of Kubernetes and maybe other technologies as well. Like when people force themselves to use Kafka and then Kubernetes, and you look at the simple application and it looks so complicated because we have complex layers on top of it. And now whenever I see like things like Kubernetes and Kafka, and I kind of have like a guard to be sure that, okay, I hope I'm not getting into like unintended complexity.
Yeah. Yeah, that is real. Like, again, I think there are many, like, Kubernetes has become this really universal, really also helpful platform. The community has done a fantastic job at making it suitable for so many applications.
Yeah,
And for many, I want to argue that for many, like many a time, Kubernetes is a good choice. Like it, especially with the advent of managed Kubernetes solutions, things like EKS, GKE, you name it, you know, Kubernetes can make a lot of sense.
true. Yeah, I have this comment here. The person says, "Hi there, and I'm planning to move more services to Docker and Kubernetes using RKE2. And now you are saying I shouldn't."
I'm not saying that at all. I'm not saying that at all. Like what I'm saying is, I think it really depends on the kind of workload that you're looking to move. If the workloads that you're having are application workloads, services that follow request response pattern, some kind of backend thing, like your typical sort of application these days, there's a it can make sense to move that to Kubernetes, right?
Yeah.
I think the time where it very definitely does not make sense to move things to Kubernetes is when you have a system workload. So for application workloads, it can make sense. For system workloads, it does not make sense.
Yeah. I would also like when you say application workload, I would also say it or think, in my opinion, that not all application workload because there are different kinds of applications. And I think we went through an era where everyone was going microservices and gRPC, and from with the benefit of hindsight, I now look at it as if the application actually merits having the microservice architecture, and you need to manage all the small like VMs or containers. I think Kubernetes is a perfect piece of that because you need to now make it easy to orchestrate these workloads. But if you have just a monolithic application, or if you have just two services and maybe at most they only talk through HTTP request response, then I feel like that is not a good reason to go for Kubernetes.
Yeah.
And that's how I see it these days. And a lot of people have either jumped to microservices, and we've seen different talks about you shouldn't use microservices, or you should use modular monolith, like I think what Shopify does. But there are also great examples for people like Netflix, I think, that has a huge Kubernetes workload, or the guys at Monzo in the UK. I think, you if you look at their setup, you can really see Kubernetes helps in this setup. You can't. It would be really hard to do it without Kubernetes.
Yeah.
And it's usually like a question of what you're understanding the problem the system solves and why you are using it. What do you think?
Yeah, that makes a lot of sense. Like it's really like Kubernetes is one hammer, right? It's one tool in the box. It's not the
Yeah,
only tool in the box. It happens to be the coolest one, so or perceived as coolest one, so it gets applied very often. But really, I think our job as engineers is to figure out what are the trade-offs that we're looking at. How can we either make the trade-off go away, or how can we navigate that well? And Kubernetes, like everything else, is a trade-off too. You're
yeah,
trading scalability, you're trading certain qualities of like self-healing qualities with complexity and cost. And so you really need to make yourself aware of, is that trade worth it? What problem am I solving is a really good question to keep asking.
yeah. I think that you really nailed it there, because as I've gotten the more experience I get, the more I realize that it's a matter of what trade-off am I making? Why do I need this system? Sometimes, I mean, we also make mistakes, and until you get to using it, then you realize, okay, actually, why do I need this? And
Yeah.
is this a good trade-off? So I think that makes sense. But so I'm just looking at the comment here. I think the folk is describing his setup. So he has a typical application like Mastodon, Synapse, Vecam, Gitea, Valky, Postgres, and his own service on deployment on Go backend or Node.js. But he's also running some apps on virtual machine directly rather than Docker. Yeah, I mean, I think those are still fine to run on Docker if you're actually it's just like some side project or something that needs to run on one computer, like one node. But if you have all this application you describe, most of them they look like standalone application that don't interact with each other, that could run without Kubernetes. But I would say if it needs to be scaled into multiple, like into a cluster, and then they're all containers that need to talk to each other, probably then it makes sense to move to Kubernetes.
Yeah, it again, really depends on what the requirements of your application are.
Yeah,
Where I've seen Kubernetes be most successful or very successful at is especially in when you have organizational boundaries that you need to uphold, when You have a sort of platform team that then others can build on top of, where they need to provide sort of a universal platform for others to interact with. And in
Yeah,
that space, Kubernetes is really successful, just because of things like namespaces, admission controllers, the RBAC system, and all the beautiful projects that have come out of the community to also help deployments and really pave the road, like help platform teams build foundations for the
yeah,
application teams to stand on.
yeah. I agree, and I think I mean the description you also gave is like a perfect fit for why you also need like microservice architecture because then that helps it uh, move around with various teams.
Yeah,
But yeah, given that, I mean, obviously Kubernetes is quite a nice piece of technology, no doubt. But I know you've also learned your lessons. So I'm curious, like, what challenges did you run into over the course of 5 or 6 years now, and how you try to solve it with Kubernetes before saying, okay, we think it's not the right fit.
yeah. So the challenges that we face are, I want to say, quite specific to what we do.
Hmm.
So that's what I alluded to earlier when I said application workloads can make sense, right? It doesn't mean they do make sense. As we just discussed, there are a lot of reasons why you might want to consider or not consider Kubernetes. But system workloads don't make sense on Kubernetes. And I can say that with such absolute, in such an absolute statement, at least let me rephrase that, development environments very likely don't make sense on Kubernetes as it stands today. And where this comes from is an application that you run has a very well-defined behavior, right? At least you would expect that. You expect a certain behavior around memory, you expect a certain behavior around CPU utilization, you expect a certain behavior around network. All of this, we observe our applications, we understand how they function, we can detect when they behave in abnormalous ways. And there are some things that we very definitely do not expect to happen. I do not expect my backend all of a sudden to run something like sudo apt-get install something, right?
Yeah,
If that happens, all alarm bells need to go off. I do not expect my backend to ever try and get some higher set of privileges. This thing needs to run as a particular user and as that user only. And in fact, I want to restrict, and Kubernetes has nice means to do that also, to restrict what permissions my application can ever get a hold of. A development environment, though, is a completely different story, right? Like in a development environment, for one, the CPU usage is not predictable at all because what happens is the user in front of the computer will write code over time. Eventually, they hit run and then CPU spikes. And the
yeah,
same is true for memory. For some time, nothing happens, or like at startup, we need to build up some indices and whatever the case may be. Then not too much happens, and then I run a bunch of tests and spawn 100 Docker containers, and all of a sudden my memory consumption goes through the roof. And as a developer, I noticed that a tool is missing, and I 100% want the ability to install that tool.
true. Yeah, maybe something is missing, or also like you said, you need to run some sudo commands to install a particular CLI.
Exactly. So the behavior of an application that we deploy in a production or production-like environment and a development environment, those two behave very differently. And the thing that platforms like Kubernetes do is they're very much tailored for the former case, right? They're very much tailored for applications. They have a lot of controls in place to, for example, limit the permissions, the capabilities that a particular process can get. And also when we look at things like the resource model and nowadays resource sharing model, like things like overbooking on a machine, all of these things in Kubernetes work because of this observable and somewhat predictable behavior that applications have and development environments do not have. And so this is fundamentally the cause of the problems that we run into.
Yeah, because with this dev environment, you don't really know. You can't predict uh, what each developer environment requires different set of privileges. Yeah, I think that also feels like when you work for some enterprise organization where you have to request permission from IT
Hmm.
to get like, oh, I need this permission to access the internet or this specific kind of site, and then there's always a fight between the devs and the IT operation about, I'm a developer, give me full access to the Kubernetes production environment. So
Hmm.
with I think with Gitpod, then you have your own specific environment without worrying about leaking secrets or not having the right permission to install maybe Docker or some other system tools that you need to run your application. These are all just already given to you by the software. And if with Kubernetes you need to configure a lot of permission models and restriction, it doesn't really scale.
Yeah, to make this concrete, like we just spoke about how as a developer, you want the ability, the permission to install something, right? Like I want to be able to run apt-get install, whatever the case may be. So I
Mhm.
need I need to be root. I need cap sysadmin and other capabilities. Now, in Kubernetes, because fundamentally it is just containers, and containers aren't really a security boundary, we have the problem that um, there isn't an inherent way to provide multiple different tenants on the same machine with these privileges if they don't trust each other. So
Mhm.
if you want to run a sort of multi-tenant type organization or application in this way, and one becomes root, you now can either have root on the entire machine, which from a security perspective is very questionable, or you can try and limit this root, quote unquote, these capabilities to the individual slice that is that development environment. And the former is the naive approach. The former is you essentially disable all the security features that Kubernetes has. And the latter requires a more nuanced approach. And we've tried to do the latter, right? And there are others who try and do that too. There are other projects that do that too. And just to give you a glimpse of what's needed to do this, for example, in Kubernetes, one of the security features is what's known as a mask proc. So your
Mask proc.
mask proc. So your slash proc is masked. And what masked means is there are bind mounts that live on top of individual files in your slash proc. And the reason that is so is that you can't read or write to those files. For example, one of these files is essentially the entire memory the kernel is aware of. Obviously, you don't want to give everyone access to this, right? Like there can be secrets in there, all that sort of thing. And the Linux kernel has a very sensible feature where if you are in a mount namespace where you have a mask proc, you cannot mount proc again, which makes a
Okay.
lot of sense. If you could, what would be the point of masking it in the first place if I could just go and mount myself a new one? So you cannot do that. Now, in order to run a Docker container, I need to be able to do that. Like Docker, like running any container, not like run C, fundamentally needs to mount proc to work well. But we just discussed that I cannot do that because it's masked for sensible reasons.
But this masked on Kubernetes, not from the container runtime level.
It is masked by Kubernetes, that's true. And so you could disable it,
Okay.
but that would be disabling a really important security feature. And so just what I'm trying to do is illustrate the lengths that one has to go through to make this work well. And so to make this work, one of the things that we had to do is we use a feature called seccomp notify, which is a seccomp profile, where whenever that rule triggers, we get a notification, and then in userland can assemble a correct proc mount and move that file descriptor through Unix sockets into your namespace. It's a very elaborate scheme. We have a 1 hour talk on YouTube, CNCF talk about how all this stuff works. And this stuff works. You can run Docker container in Gitpod, but it's very involved. There's a lot of stuff that needs to happen, and there are some things that may or may never happen. For example, running Kubernetes and such as like Kubernetes in Kubernetes in such a setup. It's one of our most upvoted questions. A lot of people want to develop with Kubernetes, and this This is if you take one thing from this conversation, if you take one learning from this conversation, it's this: to develop with Kubernetes, your development environment itself does not have to run in Kubernetes, right? This is a misconception that we run into quite often. And in fact, it makes it harder. Like, it's easier if your development environment runs over here, Kubernetes runs over here, and you have a connection between the two. It does not make sense to make your development environment part of the same cluster you're developing against.
Yeah, that's quite interesting. I think I could imagine. I wonder how long it took you to, like solve this problem of trying to enable, like having to run the secomp process and allowing them to run or install Docker also in the machine.
2 years.
Oh, wow.
It took a long time. Like, we realized pretty early on that people want to run, obviously want to run container in their development environment, right? It's not a, I mean, that's not a particularly special insight. And then it took us a while to understand how we can build this, and we were only able to build this with the help of our friends from Kinfolk, who have since joined Microsoft, and who
Okay.
are really at the leading edge of what containers can do.
What do you call that?
Kinfolk,
Kinfolk.
they were called, yeah.
Okay.
A lot of them were built Core OS, and it's like
Okay.
really, really fundamental container knowledge that went into this, and are still maintainers of Containerd and the OCI specification. So we're really in the depth, in the heart of this ecosystem.
Yeah. Feels like a challenging problem that I wonder if you were told it would be this hard to, solve this kind of problem if you would embark on that journey. Yeah, but
We
it's
would
quite interesting.
we wouldn't. At least, I mean, we would embark on the journey of solving it. I think we would go down a different avenue. We would try and solve it
Yeah.
differently, right? And again, this holds true. We don't do this because it's easy, but because we thought it was going to be easy,
Yeah.
right?
Yeah. So we've talked about the CPU challenges maybe a bit in a way, I guess, because you talked about how each application have different requirement on CPUs and memory, and maybe we should talk about also the storage parts, the challenges you face with the storage and how you solved it.
Yeah. Storage is interesting. So fundamentally, with storage, there are two problems that are closely interrelated. One is, how do you get the storage to the environment, to the workspace? And the other is, what qualities of that storage can you provide as the environment is running?
Yeah. But I think maybe also to start with is more like what kind of storage is this from the developer perspective? Like they need to store when they run the application, they want to store files or they want to run their own Minio instance, for example. I'm just curious what kind of storage.
Yeah, good question. So the storage really is everything that you do that you want persisted across restarts. This is usually how we talk about
Okay.
it. So that starts with, your Git working copy and the modifications to source code that you're making. But it is also state of applications that you're running, really everything that you want persisted when that environment shuts down and starts up again.
Okay, cool. Clear.
And so we started with what throughput, what IOPS, what bandwidth do I need as an engineer for this to feel responsive, and then be as close to the experience, even better than what I have on my laptop. And in a quest for higher and higher performance, we really leveraged SSDs in many ways, to the extreme where we would build a RAID 0 out of multiple SSDs attached to the same machine. And there are a lot of benefits to this. You get a lot of throughput, you get a lot of IOPS, more than something like, EBS, for example, can do a lot of is really great. You can get a lot of throughput there. It's not quite what you can get from SSDs at that level, and if you provision for that throughput, it will be cost prohibitive. So there is that. But once you are working with locally attached devices, what happens when that node dies? Then all your content's gone. And it's interesting because especially in the beginning, we thought a lot about this to a point where we would even create a backup every 30 seconds and upload that to S3. And we very quickly realized that that's just untenable. It's entirely saturated I/O of the machines. Doesn't work. And in practice, it shows that cloud VMs are really quite stable. We haven't, every time when we have lost workspace content, which has happened more than I care to admit, every time that has happened, it was our own fault.
Yeah,
It was
okay.
a bug. It was some scheduling problem. I say every time. When I say every time, it's probably 99.9. I'm pretty sure there's some cases where that wasn't true, but like a lot of the time, it was really a bug in software. So the thing that we learned is when it comes to stability of workspace content, when it comes to as an engineer, we're all very sensitive. Imagine you just worked on something for 4 hours straight and you lose it. It just disappears on you. There's little that's more frustrating than that. That must never happen.
Yeah.
And so the thing that we've learned is the number one risk to workspace content is the system itself. And since then, we have
The system,
doubled down,
by
like
the
any
system.
orchestration system, Gitpod or CodeSpace or whatever it is, right? Whatever provides you with that experience. And we have since doubled down on quality, on testing this, on really making sure that we got the logic right. Really have essentially a zero tolerance policy against such bugs, and
Yeah,
that's greatly helped too.
because then the likelihood of it happening on the hardware level or on the cloud Kubernetes provider is lower than if it's like a bug.
Yeah, and
And
the reason, one thing to consider here is that people start and stop their environments quite often, right?
yeah,
So it's not like you need to be running for 20 days and it must never crash in 20 days. That's not what we're talking about. This is not a production database that needs to be up for so often or so long. But it's development environments that get started and stopped possibly multiple times a day. And so you are creating these backups regularly and
yeah.
entering on a different node also.
And so you tried the solution of backing up and sending to S3, which probably is also quite expensive if you have to do regular S3 interaction. But um, which solution within Kubernetes did you end up doing? Because you tried SSD RAID, you tried the block EBS, and what did you end up doing?
Yeah. We ended up doing literally that as three thing. We just didn't do it regularly. So it
Okay.
was whenever, like regularly in the sense of every n minutes or something. Instead, it is whenever you start or stop your environment, your workspace, we will download that archive and untar it. And whenever the environment gets stopped, whenever the workspace gets stopped, we'll create an archive from that and upload it again. And in fact, this is the most cost-effective solution we have found so far. S3 is incredibly cheap. If you compare that to any other storage solution within Amazon, it's very cheap. If you take care of things like regionality and ACs, and you don't pay sort of inter-region traffic, it's a very affordable solution.
Yeah, yeah, it doesn't. I mean, compared to other storage solutions, like you mentioned.
Yeah, exactly. Like also compared to say PVCs backed by EBS or the likes.
Yeah. So we've covered the storage solution. We looked a bit at CPU and a memory. Is there any other piece of challenges that we didn't touch on?
Yeah, so very fundamentally, it's three classes of challenges, and we've talked about most of them. One is security. How do you
Yeah,
produce good security boundaries between these different workspaces? And we've touched on that. The other is resource sharing. So overbooking, but also making sure everyone gets their fair share. And the third one is startup times. We haven't yet talked much about startup times. And startup times are interesting because fundamentally the defining quality of such a system isn't so much the absolute time in which an environment starts. There clearly is an upper limit for what's acceptable. But what's more important than the absolute time is the consistency. If one day your environment starts in 10 seconds and the next day it takes 2 minutes, that is not acceptable. You want some understanding. All right, I click start. Should I now go and open a new tab and read the news, or can I sit here and wait? Right? Like there's this kind of behavior that gets shaped this way.
Yeah.
And again, there is an upper limit. We have relentlessly tried to optimize for workspace startup time, and to a point where we've come up with novel solutions to, for example, improve the caching of container layers across different nodes. There's a KubeCon talk from 22 where we talk about such a solution that uses IPFS and a custom pull-through registry cache to improve the startup times. And one thing that's made this quest for startup times harder is harder and easier is the fact that you have multiple environments on one machine. Right? The intuitive thing is to go, well, we're going to have caches on this machine, and then every environment that starts up on this machine is going to benefit directly from those caches. They're already on the disk. It's going to be incredibly fast. And that's true. If you have enough reuse of image layers for that to actually work. And so what we found is that in environments that use largely the same workspace images, commonly found in companies, for example, these startup times can get incredibly fast. We can get this to below 10 seconds. So you click a button, in less than 10 seconds, your environment is up. In practice, when there's variants introduced and you have multiple different environments and images, which you will likely have below a certain scale at least, these times vary greatly. And the startup times become all but unpredictable, because so much of it is based on this caching, on this cache locality. And the moment you have all this variance on images, your cache reuse goes out of the window. And so it's really difficult to predict what these startup times are. And as I mentioned, I think the thing that really matters is consistency in startup time, less so the absolute value. And it becomes quite difficult in this setup to provide consistent startup times.
And you mentioned you use IPFS to solve it?
So IPFS has helped. Fundamentally, this is all a game of trying to get as much of what you'll likely need as close to the node as you can, right? The less time you have to spend downloading or extracting, the faster you'll be.
Yeah.
And we've used IPFS to supplement the node local caches with caches that are on the surrounding nodes, trying to exploit network locality.
Yeah.
And that has worked quite well.
And what's IPFS?
What do you mean?
What do you mean by IPFS? I mean, for how does it help with this situation?
So the way we do that is we take the individual blobs that are referenced by. So in OCI, I don't know how familiar your viewers are with OCI, but just for the benefit, fundamentally, when you do a Docker pull on something, what gets first downloaded is possibly a manifest index. But if you jump that, you download a manifest, and then that manifest refers to different layers, blobs in OCI speak. And these blobs are really the expensive thing to be downloaded. And so what we've done is we've essentially opportunistically injected these blobs into an IPFS cluster. And then the challenge that remains is mapping the SHA hashes of these blobs to the IPFS addresses. But once you have that solved, instead of needing to pull these blobs from a remote registry, something like ECR or Docker Hub, which is
Oh, yeah.
potentially slow, you can pull that out of the IPFS cluster, which is going to be a lot quicker.
I see. That's interesting. I I I I mean, the describing it like this feels more like how do I say, kind of like what a CDN does in some sense, trying to bring data together. And I know the guys at Tigris Data have an S3 solution, and I think their S3 solution behind the scenes also tries to do something similar. Maybe they use IPFS as well, but I think if you access the data within the S3 um, bucket from various regions, it caches them within the within those regions. And then I think in this case, if this kind of S3 solution does that, maybe not needing IPFS is probably also an option, but because it caches them from various regions where data are accessed from.
Yeah. Yeah, I think that the pattern might be very similar here. The key thing that made this work is the fact that it's opportunistic. It doesn't have to be preloaded. You don't have to precede what needs to be cached, but the
Okay.
system learns itself what is cached and
Oh, I see.
has a certain budget expressed in gigabytes that is allowed to store, and that gives you a lever to essentially scale cost versus startup time.
And that's interesting. I probably should check more out about the IPFS. I haven't worked with it or seen people use it that much.
Yeah, there's a KubeCon talk that we gave in Detroit. Um, Opportunistic image caching using registry facade and IPFS, I think it was called.
Opportunistic.
Image caching. Let me see if I can find that real quick. Found it. It's
Fast image pools
That's
using
the one.
IPFS. Okay,
Yeah.
go to check it out. Yeah, interesting. So I think those are quite interesting challenges, and I could only imagine how tough it must have been, trying to get this, especially when you talk about the locality and how you want consistent, fast startup time for them. I wonder how much effort, trying to find out the right solution, how to use them, and yeah,
It's a lot of fun. Like, I also want to obviously mention that all of this can only work because of the team, right? We have a world-class team, really fantastic people, incredible, and only because of that does this work. Like, it's the way we show up, the way we think about the problems that we need to solve, and only because of that.
yeah, that's quite impressive. Yeah. I was going to say something, but I lost my train of thought there.
All is well.
uh, So I guess I mean at this point probably makes sense to also talk about what uh, you solved. I know I talking about your solution with the startup time. I just remembered what I was thinking about the other time, which was um, not just the startup time. If these are all like layers. You if you run on, let's say, a cloud VM, and then the cloud VM runs Kubernetes, and then Kubernetes also runs like containers, and the users are installing Docker on that as well. That's different layers of user space and kernel interaction. I think that also makes it slow.
It does come at a performance penalty. That said, like, containers are very effective, right? Like, from a performance cost perspective, they're really good, especially if you compare it to things like micro VMs or VMs in general. I mean, they've also become fantastic at this point, but containers really have a bit of an edge here. So it's, I think, more so than the performance penalty of it, there is a complexity cost to it. Every layer of indirection adds complexity to understanding the system as a whole and potentially understanding failure modes that occur. And so, really, it's I think the complexity that we're paying with in
Oh
such
yeah.
setups.
Okay. Before we go to the next question or section, so the comment from Facebook you mentioned asked, can he give an example of system workload? But I think you clarified that it's like running developer environment. So I don't know if there's any extra stuff you want to add about what you mean by system workload, but I think that clears it.
Yeah, development environments are a really good example of what a system workload is. Like fundamentally, I think the way you can visualize that is like an application workload is when you run a process. Like I'm grossly simplifying here, but is fundamentally when you run an individual process like Node or Go, a Go process or whatever the case may be. And a system workload is something that really looks and feels like a machine. It looks and feels like a virtual machine or your laptop or whatever the case may be, where you have certain expectations as to what you can do with it. And common expectations are that you have full control over the networking, that you can run container runtimes, that you can run more like higher level orchestration platforms like Kubernetes.
Yeah. And I think this databases are also system workloads, but then how to deploy apps with databases? Same is true for maybe a Nextcloud. That is basically a file server in a sense.
Yeah, databases are interesting, right? Like when you look at the history of Kubernetes and databases, you can see this exact conversation. What are databases? Should they be running Kubernetes or should they not be running Kubernetes? Are stateful sets a good choice here? Like I think it's exactly like they're so on the edge of this particular categorization, and one can also question the taxonomy itself. But they're just so on the edge that this has been a very lively conversation in the community over the years.
Yeah, I started with the notion because I heard a lot of people talk about it on the side and also in talks. Don't run databases on Kubernetes. And then recently, like last year and this year, I see people saying, oh, it's quite easier to run databases on Kubernetes. I don't know which company, but I know they gave talks about how they actually, maybe the folks from Planet Scale, I'm not sure, or Netflix, they gave examples of how they are running databases on Kubernetes and made really good points. And it probably also comes down to experience. Like if you don't have this certain kind of experience or world class team to be able to do that kind of work, you may really struggle to do that. So because it's also not common knowledge to just Google and you go to YouTube and you see all the information on how to do this thing, like what your team did. You have to do a lot of research, work with guys from different companies, and
Yeah,
go on the very very low level part of the stack. And yeah, I think that's quite interesting.
for sure.
Yeah, but then I'm curious, like what is the new setup now? Is Kubernetes still involved? I mean, for the environment, or how have you evolved the solution to
Yeah.
to not use Kubernetes?
So I think fundamentally what we've done is we've thought more deeply about what it is that we're running and what are the different sort of categories, or what is the structure of development environments. And what we found is that it's almost a bit like an onion what's happening here. And I'm going to use the very generic terms first and then give more concrete examples for
Okay.
instances of this architecture. So very fundamentally, we talk about it in this way. We have a unit of compute that gives us some compute substrate. Can be a VM, can be a laptop. The fundamental purpose of it is to give us system level compute. On this unit of compute, we run what we call a unit of isolation. And the purpose of a unit of isolation is on this unit of compute to isolate individual workloads. A very common example for something like that would be micro VMs. They're a very good way to provide a unit of isolation. The unit of isolation also, like, it acts as the sort of resource isolation that isolates resource use so you don't get noisy neighbor effects.
Yeah.
But it also acts as a security boundary between these different workloads. And then inside this unit of isolation, we run the development environment itself, typically in the form of a container. Dev container is a very common choice, is also the choice that we've adopted. And so you have this onion of unit of compute, unit of isolations, and in there you have a dev container. And you could map this back directly to Kubernetes. Kubernetes fits exactly in this description. The node is the unit of compute. The container becomes the unit of isolation. and it is the same as the development environment. That's fundamentally how classic functions, or how the Gitpod that we've built over the years functions. The thing that makes that challenging is that containers as a unit of isolation fall short. They don't provide a security boundary. They don't provide strong enough resource isolation guarantees. And so other ways to run this would be to use micro VMs as unit of isolation. Firecracker. There are projects that introduce micro VMs in Kubernetes. KubeVirt
Oh,
comes to mind, right? So that would be one way to run it.
what
Another way,
about like Kata containers? I don't know much about it, but
yeah,
it was just on my radar recently.
sure. Kafka is another way to do the orchestration of these micro VMs. So there are ways to run it this way. Then the thing that is still challenging is how you move content from A to B. How do you get content to that machine? There's also cost factors, and very specifically the fact that development environments are, at least day to day, are extremely stateful, and service interruption is directly noticeable, right? You have a one-to-one connection between the person interacting with the development environment and your workload, which is unlike common applications where you have multiple servers serving one user. You make a request, you get routed load balance to whatever server. You don't notice if one goes down. But with the development environment, you very much notice when your development environment goes down. You can't just take this thing offline, migrate it somewhere else, and bring it back up, at least not easily. And so you have this extremely stateful setup, which one of the consequences that we found is that running multiple units of isolation on one unit of compute can lead to drastic underutilization of whatever unit of compute is, because typically that's what you pay for. If that unit of compute is an AWS VM, they're going to charge you for the entire VM, not just the portion you're using, right?
Yeah.
So there's a utilization factor here that plays a role, which makes such also micro VM based solutions economically challenging. Not unattractive, not impossible, just more difficult.
Even if you use micro VM.
Yeah,
But
again, you pay for the entire machine, right? If you want to run a micro VM on AWS, unless you use more advanced, like the standard way to run this is using KVM, right? So you need a metal instance. The smallest metal instance, I believe, I might be wrong, but I believe is to the tune of 48 CPUs.
okay.
So you need to be running a machine with 48 CPUs. If now you only have 2 developers on this and you can't migrate them away, you're paying a 48 CPU machine for 2 developers. There goes your cost efficiency, right? So there is a very strong economic incentive to align the size of compute you're using with an individual development environment, so that once the development environment isn't used anymore, you can shut down the compute and then stop paying.
Okay. Yeah.
I'm afraid we're coming up on time, and I have a reasonably hard bump.
Do you have more time, or you need to?
Not a whole lot. I really do need to drop. So
Yeah. Well, but anyway, I guess you made some. You explained what the challenge is, but maybe just summarize what you moved to, like what the setup is, if you using micro VM or not.
yeah, so we did move to fundamentally a VM-based setup where there's a pretty much one-to-one alignment between development environments and VMs, and making that work well also comes with its challenges. There is no free lunch, but what it does do is it aligns nicely. It aligns sort of cost domains, failure domains, resource domains with that individual development environment, and that has turned out to be to produce a quite favorable experience and system overall.
And this is like a hypervisor VM or like AWS VM, or is it a micro VM?
That really depends on where it's running.
Okay.
It can be cloud native VM, literally an EC2 instance. It can be a micro VM. In case of your MacBook, it is using the Apple virtualization framework, so it's those VMs. It really
Okay.
depends where it's running.
Okay. Then that's interesting. So different workload for different kind of VM.
Yeah.
Did you consider unikernels?
So unikernels have exactly the same challenge that
Uh,
containers have, right? Like unikernels are great if you're running applications and they work well for applications, but fundamentally the interface that system workloads like development environments have is the Linux kernel. So we can't just go and swap that out
okay.
for a Go specific runtime or whatever the unikernel would be.
Well, that's interesting because I saw about unikernel last week, and it's been like an interesting thing to see how people are using it. So,
Yeah, unikernels are really interesting, but obviously in this case they're not applicable.
all right. Thanks a lot, Chris, for the time. Like I said before, that sometimes we get on time and then we couldn't even talk more about it. But I appreciate your time, and I hope anyone that's curious about the full setup, I think you described it, some of it in the blog post. So if you go to gitpod.io/blog, you would find the article and you can check more about the final solution, which we didn't get to talk about. And see you next week for the next episode, which will be about web performance. We will do some live web performance audits, so maybe you can learn. But otherwise, see you next week and have a good time, listeners.